Hi, welcome to Math 1300, Nunez Community College. This section will be section 5.5 today, and we're dealing with the properties of logarithms. First of all, in one of our former videos, we talked about the general log properties. We'll go ahead and state them one more time. The general log properties . The general log properties, we have four of them. There's log base b of b to the power of x. If that's what we come up with, the answer is x. So if the base is the same as the exponent, then it's the answer is whatever the exponent is. We have log base b of b is equal to 1. Another one is log base b of 1 equals 0, and b to the log base b of x is equal to x. Again, in the former video, we explained how all this works, but if this occurs, the answer is each one of the things that you see here. In example number 1, we're going to show examples of this. Suppose I have log base 7 of 7 to the third power. That would be an example of the first one. The bases, we have the same number, so therefore the answer is 3. Suppose we have log base 4 of 4. Log base 4 of 4 looks like this one, so the answer is 1. Using the same general properties, if I have log base 3 of 1, you're just going to simply put the answer is 0. And then finally, if I have b to the log base b of 2, the answer would be 2. So this is an example of using the general log properties. In example number 2, we're going to do something called a change of base formula. The change of base formula. So if I have log or natural log, as seen in a former video, and we're trying to figure out the value, we can just punch it into the calculator. But if I have log base 7 of 5, I can't put that into the calculator because the calculator does not do log base 7. It only does log, which is log base 10, or natural log, which is log base e. So what we do here is we do something called a change of base formula. And it states that if we have log base b of x, then we can find the value by taking log of x over log of b. So our two numbers here, we would change it to log, which is log base 10 of x over log base 10 of b. That would give us the answer to a log of a base that we don't know. Now, I can also write it another way. Since this would be log base 10 over log base 10, I could also write it as natural log of x over natural log of b. Either one of them would give me the exact same answer. So if I have this one, log base 7 of 5, we actually log base 3 of 5. So it has, can't see anymore. Log base 3 of 5 would be log of 5 over log of 3, using a change of base formula. If you punch that into the calculator, you will get approximately 1.4649. Make sure that that's what you're going to get. Or you can do it as natural log of 5 over natural log of 3. And again, you would get approximately 1.4649. The same number, using change of base either way. Now the next thing that we have after the change of base formula is going to be expanding logs. So we're going to be given logs that we can write as something that is larger. So the first rule that we have is called the product rule. The product rule. And the product rule means to multiply together. So the product rule states log base b of m times n, the product of two things multiplied together. We can expand this by saying that this is equal to the log base b of m plus the log base b of n. This is known as the product rule. So in an example, they may say, expand the log. Expand the log. And they're going to give us log base 4 of 7 times 5. If this is what they gave us, then we would say, by using the product rule, these two are multiplied together. This could be written as log base 4 of 7 plus log base 4 of 5. This would be expanding the log using the product rule. Now, when expanding the logs using the product rule, though, you must make sure that none of the general log properties come into play. For instance, if I have log, which remember, that's a common log, log base 10, of 10x, which is, again, a product rule because it's 10 times x. We could write this as log of 10 plus log of x. However, log of 10 is one of the general log properties that we found or we looked at. Log of 10 is 1. So we would have to simplify it to 1 plus log of x. This is what we'd have for the answer. It must be written in as simple as terms as possible. That is the power rule. We also have something called a quotient rule. A quotient rule. And just like the product, we multiply them together. With a quotient, we are going to divide. So the quotient rule states that log base b of m over n divided. Well, if the product means we add them, then the quotient means subtract them. Log base b of m minus log base b of n. And so again, it's going to say use the quotient rule in order to expand the log. Suppose we have log base 7 of 19 over x. That would be a quotient. We would write this as log base 7 of 19 minus log base 7 of x. Just like in the product rule, though, you may have something that, because of the general log properties, simplifies. Suppose we have natural log of e to the x over 7. E to the x over 7. Actually, it's e to the third over 7. We're going to write this as natural log of e to the third minus natural log of 7. Now remember, natural log means log base e. So this would be log base e of e to a number. So therefore, this would be 3. 3 minus natural log of 7. So again, if it simplifies, we must simplify it when writing the answer. We must simplify it when writing the answer. And lastly, we have, after the product rule and the quotient rule, we have something called the power rule. The power rule. The power rule allows us to take the exponent and bring the power up front. So if I have log base b of m to the power of r, that would allow me to bring the power out front. It's going to be r times log base b of m. That is the power rule. So again, that's also expanding when we do a power. So if they say expand each log, we could have log base 5 of 7 to the 4th power. And if I'm expanding this, the only thing I can do is the power rule, bring it out front. That is 4 log base 5 of 7. Now, suppose we have a square root. Suppose we have a square root. Suppose we have natural log of the square root of 7. Natural log of the square root of 7. If this is the case, then this could be written as natural log of 7 to the 1/2 power. 7 to the 1/2 power. Square root means the power as a division. Means the power as a fraction. So therefore, this can come out front. This would be 1/2 natural log of 7. 1/2 natural log of 7. Now we can combine these things. We can put things together. If we were going to combine them, we would use the rules exactly like we have them here. So suppose we have, which is the next example, which is example number 6. Suppose we have expand the logs, and I have log base b of x squared square root of y, x squared square root of y. This would be several different things. The first thing we would have is going to be the product rule. That's going to give me log base b of x squared plus log base b. Instead of square root of y, I'm going to put y to the 1/2 power. Why am I going to do that? Because in the next step, we're going to do the power rule for both of these and bring it out to 2 log base b of x plus 1/2 log base b of y. This would be the expanding of things when we have more than one rule to apply. Now likewise, on the next one, we could have something where we might have all 3. Suppose I have log base 6 of the cube root of x over 36y to the 4th. 36y to the 4th. This has about everything that we can possibly have in one of these. The first thing we're going to have is we're going to have what? The quotient rule along with the product rule. So we're going to have log base 6 of x to the 1/3 power. Since it's the cube root of x, we're going to write it as an exponent, minus this whole thing, which is what? Log base 6 of 36. These are multiplied together, so plus log base 6 of y to the 4th. But as you can see, the whole thing is at the bottom, so this is going to be distributed to both. So we'll have log base 6 of x to the 1/3 minus log base 6 of 36 minus log base 6 of y to the 4th. Now I'm, in the next step, going to look at this and I can simplify this because log base 6 of 36 can be rewritten as log base 6 of 6 squared. 6 squared is 36. Then allowing me to use the property to say that this answer is 2. So this thing simplifies to the number 2. So I'm going to bring the power rule out front, 1/3 log base 6 of x minus, we said this is 2, minus, I'm going to bring that out front, 4 log base 6 of y. This is the whole thing, putting all of our properties together. Now, we can also go backwards with this property, with all of what we have here. We can take the end product and write it as a single log. You can take the end product and write it as a single log. So for this, we may have, write as a single log, log base 4 of 2 plus log base 4 of 32. In this one, we don't have any power rules to do, but we do see that it's added, so therefore that's the product rule. So this will be log base 4 of 2 times 32, which is log base 4 of 64. Now when doing that, you have to be careful because if the base can be written, if the number can be written as that base, we have to do it. So this could be log base 4 of 4 to the 3rd power, because 4 to the 3rd power is 64. And then this simplifies to simply 3. So the answer would be 3. And finally, we may have one that looks like this. 4 log base b of x, 4 log base b of x, minus 2 log base b of 6, minus 1/2 log base b of y. Okay, with this one here, I'm going to do the power rules first, because that's what we do when we put them together. That's the last thing we do when we expand them, but the first thing we do when we put them together. This would be log base b of x to the 4th minus log base b of 6 squared minus log base b of y to the 1/2. Now I'm going to say that 6 squared is 36. I'm going to say y to the 1/2 is the square root of y. Both of these are minuses, so they both go at the bottom. So I have log base b of x to the 4th on top over 36 square root of y. Put it in parentheses because it's the log of the whole thing, not the log of just the top or the log of just the bottom. So this would be writing all of this as a single log. And that concludes this section, which is on logarithms, and I will see you at the next one.